Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward. All right, welcome to Happy Path Programming. Oh, it's been a little while.
Yes,
I've been on the road.
September 19th, 2025.
Yeah.
You've been on the road a lot. Yeah, we've had all kinds of things going on. So
we had a few people come up to that was going to be the Summer Tech Forum Unconference, but turned out to just be some delightful time with our friends Bill and Diane.
Bill Venners and Diane Marsh, who
Yeah.
we haven't seen up here in quite a while, and
Yeah.
it was great. We mostly bicycled and hiked and hung out at restaurants, and we hardly talked about programming at all.
But you did meet with the Western University students.
We did a panel. We did a panel where each of us gave a 5-minute presentation. The panel was called Adapting to Disruptive Technologies or something like that, which mostly was AI, because the students are concerned about whether they've made a huge mistake in choosing computer science as their job. And we kind of said, we've seen this before. It's kind of, and everybody's going, oh, but AI is different, and it's like,
continues to be hard problems to solve that require humans and thought.
In fact, lots and lots of hard problems haven't been able to be solved because they cost too much, and AI allows us to solve those problems.
Great.
But
so you
humans
got the students excited to stay
and they asked lots of questions and everything. So it was very satisfying for all of us. So,
That's great.
The other thing is we did nail down, because we have a group of students coming from Western for the conference. We did nail down the Winter Tech Forum will be the first week of March. I don't remember the exact dates, but
it's probably on the website.
It will be on the website soon. So
great.
Anyway, start planning for that if you're hoping to come this year.
Yeah.
All right.
Great. Okay, so today we have with us Sam Goodwin. Goodwin, right?
Goodwin. Yeah, you got it. Yeah.
So the story with Sam and my connection with him was, this was maybe a month or so ago. I reached out to our friends at the Effect company, the people doing TypeScript Effect, and I was like, hey, I think that there's some potentially really interesting things we could do to revolutionize infrastructure as code related to Effect. And they're like, oh, Sam, just check out Sam. He's already building this and creating a whole new foundation to fix all the problems with infrastructure as code. And so then I was like, oh my God, Sam, yeah, he is and this is amazing. So we got to have him on. And I reached out, and then in one of our Twitter threads, Michael Arnaldi from Effect said, you should have Sam on the podcast. And so here we are. So Sam, good to have you. Maybe where I want to start is, infrastructure as code was probably a good step forward from where we were before that, which was, certainly worse. But I've always been kind of disappointed that a lot of the things that I have as an application developer when it comes to writing code, like debuggability, testability, rational flow and things, I don't have those in the infrastructure as code world. And it always left me longing for it to be more like code. And so I don't know, what's your take on the state of infrastructure as code?
Well, the way that I think about infrastructure code right now, it's just like a leaning tower of Pisa is sort of how I think about it. It's just so many layers on top of layers, right? So I like to point at the example of sort of the highest level infrastructure as code experience before Alchemy was SST, right?
Yeah.
And SST's SST.dev. So it's like a TypeScript framework for deploying AWS apps is what it is. But it's built on top of Pulumi, which is an infrastructure as code tool, which is actually generated from Terraform, which is the real infrastructure as code tool, which is a bunch of code written in Go. And it's this huge ecosystem. So you're up here working in TypeScript, and you have to understand all these interesting layers all the way to the bottom. And at the end of the day, it's really just calling a few APIs for you, right? Calls the APIs in the right order. That's what it's doing. And it's why can't I just do that myself, right? Like I understand that we needed to solve that problem. CloudFormation, Terraform, they came along and they said, look, yes, calling APIs yourself and managing the state is chaos. What we need is a more declarative system. That's a good idea, right? But having to do everything through these layers like CloudFormation or Terraform has just led to this complexity explosion.
Yeah.
And every time I
like
want
abstraction on top of abstraction, where
Yeah.
underneath the covers, it's like state management and calling APIs, right? And like, why
yeah, I like to say
so
it just
hard?
when I was pitching it back in March, I would say just to call fetch. That's all it does is call fetch in the right order. That's all it does. And if you put it in those terms, you realize, oh wait, this is actually pretty simple. And another thing I'd say is it's very broad, but most people just need a very small subset of that breadth, right? Like how many people use every AWS service or the 1,000 Azure services? No, they got like a Lambda function, a table, and a database, right? Like there's a nice subset here that if you can nail down with what I like is like a handwritten experience, I think it ends up with being a lot better. So like Alchemy kind of started out of I tried everything, and I've always been obsessed with building a new abstraction on top, like adding another layer on top. And every time I would just get stuck with, oh, it's in some Go code, or no, it tries to serialize it. It does like so many different hacks that it does, and I just wanted
the debuggability is like you would have to know where the problem was occurring in all these layers.
Yeah, and you can't change any of it. Like you get what you want to change in Terraform. So submit an issue, wait 3 months. Then it gets merged. Wait more time for it to end up in Pulumi. It gets merged. Wait for SST to update their version of Pulumi. You know, like it gets crazy, right? Where
those abstractions generally don't give you the escape hatches that you may need to like unravel the thing and then inject some other thing in, and it's just because we've built all these abstractions on top of abstractions, it becomes really hard to untangle them all.
Which is expedient for experimentation and trying to figure out, oh, what should this thing look like, but maybe not for actual use.
But it's just another example, I think, of where infrastructure as code isn't generally giving me the benefits of being in code.
I don't think anybody's treated it as a first-class problem, like a first-class computer science problem, but I think that's what you're trying to do, right?
Well, the thing to observe about infrastructure as code is it's declarative at the end of the day. Like, it works best when it's declarative. I kind of deviated from that with the first version of Alchemy. I was like, get out of my way, give me async functions, because every infrastructure as code tool has some wonky graph abstraction in order to be able to declare your infrastructure, analyze it, look at a plan, make a change, those kinds of things. You need this graph abstraction. And with that, you always end up with losing power. Now you're not actually in code anymore, right? Now you're in their abstraction. And that becomes limiting. So I threw all that away and I was like, look, it looks more like a durable workflow. Like a durable workflow is like a memoized bunch of function calls. So if you've already created the table, just skip it and give me the props. Or if the properties are changed, update it. You know, so you can just run that as a memoized function. So that's what Alchemy started as, right? It's like async await. It's just a script. You can await promise.all. You can loop over these things. You can build nested stuff, and like that power has proven to be.
And you can just call like the base APIs on your infrastructure provider if you need to. I was experimenting with that in Alchemy. I'm like, okay, this thing doesn't exist in Alchemy at the time, but I know that there's an API to do this on AWS. And normally in most of the IAC platforms that I've used, that means like, oh, the escape hatch is pretty gross when you need to take it for how you actually just end up calling fetch, right, to that API.
It's always gross, man. Like, so like, let's look at that. Terraform. Well, I've never gone down to that layer. That just seems like insane to me. I don't even like create a package, publish it, make it so it integrates into Terraform. That's complex. CDK, you got to define a Lambda function. So like I have to deploy infrastructure so I can implement my own infrastructure. You know, like it's backwards, and that's very complicated, right? And then if you mess up, you're waiting like 2 hours, or if you forget to misconfigure it, so you go out and get a coffee and you don't make any progress, right?
Oh, I've so been
Or if
there
you go
so
with
many times. It's
yeah,
so painful.
or if you
Yeah,
go with
another
Balloon,
place where IAC for me just totally fails is on
yeah,
the iteration loop. Like you're saying, it's like, oh my God, why do I have to wait hours just to get the error message?
yeah, I know. Yeah.
Painful.
And why can't I control C and
Yeah.
kill it, and just
Hmm.
stop it?
When did you kind of come across the idea of using effects for to solve this problem?
Yeah, well, effect is my new thing because uh, maybe like I've been watching it for a while, but maybe like a month or two ago, it clicked that it solved this age-old problem that I've been thinking about since probably 2019. I built a thing called Punch Card,
Huh.
which was again the same idea of merging infrastructure and runtime code. And the cool thing that it had was inferred IAM policies,
Yeah.
but they weren't really inferred. They were like hacked together. It wasn't very principled, right? But I moved on from that. I was like, no, this is a compiler problem. What I need to do is I need to statically analyze the code and see what resources you're interacting with, because the resources I call get item on a table. Well, I need get item permission to that table. Or if I write put item or put object, I need those permissions, right? So you can infer it from the code. So I have built a lot of hacky compiler
I
hacks
can
on
see how
top of
you would get to
TypeScript.
like a compiler plugin to be able to do that analysis to then infer
Yeah.
IAM policies.
And then the other problem is, so I inferred IAM policies. That was actually easier than the next problem, which is closure serialization, which is like, how do you extract the code that needs to go into the Lambda function and drop all the infrastructure code? Because that's heavy, right? Infrastructure code might blow your bundle up by like 50 megabytes. You need like 20 kilobyte script and you've got 50 megabytes, so you cold start. So I always thought about it through that way, and I've been thinking about that for a while. And then when I saw effect, I'm like, oh, requirements channel. The requirements channel, like it's an IAM policy is effectively a side effect.
Yeah.
It's kind of what it is. It's a static side effect. You can model it, extract it out of the type. So when I started playing with effect maybe a month or so ago, and I learned about context and requirements, I was like, oh, boom, inferred IAM policies. We can do it this way. And then I was like, okay, great. And this can also solve the other problem in Alchemy of making it more declarative. So effect is pure, right? Alchemy right now is just a bunch of async functions. Those are eager. They just evaluate instantly. So you cannot do any planning. And planning, depending on who you are, planning is a showstopper, right? So I was like,
Well,
okay,
and just on the developer experience side, you can, when you have something that can create a plan for you, then you can review the plan before you actually deploy it, which would allows me to then have a much better tight iteration loop before I actually go to the longer one of actually mutating infrastructure.
Yeah, and especially for like really annoying things like you forgot an IAM policy, right? Like with the new Alchemy effect, that talk about feedback loop, it's instant. Like the compiler will just complain and say, hey, you're missing this policy and you have to add it, right? And I actually like the process of adding it explicitly. Like I've gone back and forth on this of it should all be inferred, and you can look back at different attempts of this. Like there are programming languages for it. They always end up having to build some way of confirming that's what you wanted. Well, an explicit adding of the policy that's type checked is a really nice way to do that.
Yeah.
So you can just sit there and write your code until it compiles. Now you know your IAM policies are correct. You know your environment variable is correct. And you almost know your logic's correct because the whole thing's type checked by effect. Yeah. And then you can run it locally. Cool.
Yeah.
Then finally deploy, right? Like I think they call this concept shift left. It's a marketing term, but I like to say there's no further left than the compiler. Right, like that is as far as you can go in terms of like guaranteeing correctness of your application.
The only thing that's a little bit further left is your IDE giving you red squigglies, which is essentially still generally running the compiler, or at least some understanding of type checking. But yeah, I think you're right. It's like you want to know as soon as possible that something is wrong with your types, and then you maybe want to run it or test it or whatever locally. And so you've got this kind of layers that you want to expand out to, with production being, the furthest out. But
are you using is it layers in Zio?
Yeah,
Is that what they are?
in Effect.
And
in Zio,
Effect also
yeah.
calls it layers.
Yeah.
It seems like that would be a particularly useful thing for what you're trying to do.
Well, layers are perfect because remember that problem of closure serialization, which is a nasty problem that you should not do in TypeScript? It completely eliminates that problem. So I can write all the code in reference to some big heavy provider that's going to be provided through a layer later. But I'll only provide that to the infrastructure portion. To the handler, I'll just provide the clients. So there's no more need for closure serialization. You get an optimally tree shaken runtime handler and it can have the types of the infrastructure, but doesn't have the bundle impact of the infrastructure. So it solves that in a more principled way versus trying to shoehorn closure serialization into a language that doesn't support it.
And then because it's built on layers, presumably you could even write like tests around your infrastructure and provide different like test layers and validate your infrastructure, which is another problem I have with traditional IAC is there's no way to like unit test your IAC code.
Yeah, and like there's tools like local stack, which I find really complicated. I'd much rather just provide a layer in there. Like there's the prod deploy layer and there's the dev mode layer. Just provide the dev mode layer, exactly. And that'll just emulate everything locally, right? Yeah. So lots of things you can do with layers.
That's cool. So maybe real quick, stepping back to Alchemy, just give us the pitch on Alchemy, where what it is, where it started, and where it's at now, and then we can jump back to the effect pieces of it.
Okay, where it is now. So it's currently I call it infrastructure as TypeScript, and it's very heavily focused on Cloudflare right now. So there was a big hole in the market for infrastructure as code plus Cloudflare. No one had done that well, primarily because their API is just terrible. Like they do not have the API culture of Amazon. And so people were generating things with Terraform, and SST was trying to do stuff, but it's very limiting. But I just jumped straight in and just raw implemented it with Fetch. Just figured out all the APIs. There's a lot of hidden APIs. So just implemented that in pure TypeScript, where every resource is just an async function. That's all it is. So if you want to add a new resource, just add an async function, implement the lifecycle, and then you can just integrate it into your application. It supports deploying. It supports live watch deploying. So one cool thing is because it's pure TypeScript, you can just run bun -- watch, and it will automatically do the same thing of every time you change your infrastructure, redeploy. And because it's in pure TypeScript, it's super fast. That's probably my favorite thing about Alchemy. You don't have to wait 30 seconds. It just goes bang, redeploy. And we also have a dev mode which runs it locally in what's called Miniflare. So Miniflare is like a locally implemented copy of Cloudflare. So you get a really tight feedback loop. And it supports all the main web frameworks integrated together into a single sort of application. The final thing it does is, unlike Effect, it goes the other way. You write your infrastructure, and then we infer what are called bindings that you can use at your runtime. So that's a type that represents the table you want to interact with, the database you need to call, the bucket you can put. So you still get that nice type safety, but it goes from infrastructure to runtime. Effect goes from runtime to infrastructure. Yeah. So it's the other way around. It's a really lightweight TypeScript framework, heavily focused on Cloudflare, with support for some other things like Stripe, PlanetScale, Neon, things like that. Yeah.
AWS. I played with the AWS one.
Yeah, there's some AWS stuff. It's definitely not good enough on AWS. We integrated with the Control API, which is effectively CloudFormation over API. It's very slow. It's imperfect. We've got some handwritten resources, and I'm also working on my own Effect client for the AWS SDK, where I have ideas to generate resources that are guaranteed to be correct through static checking of the Effect flow for the resources. Nice. So that's sort of where I'm going there. Yeah.
So you started with Alchemy as infrastructure as TypeScript and much better developer experience, and you can use it bundling the infrastructure as code and your actual application code, and you get some benefits. And was that the bindings that you mentioned, or?
Yeah. It's a type only link, right? So like you don't import the infrastructure into your runtime. You just import the types. So you can say the type of this worker's environment, and then you use that in the worker, and that's basically all the you don't have to instantiate clients in Cloudflare. You just get a thing called bindings. You go env dot, and then they're all there, and you can interact with them. So that's a nice little experience. But it's suboptimal compared to effect because it goes the wrong way round. So if you don't use a binding, you'll still have it there. And with effect, I can guarantee minimal. Like it's exactly what you need, no more, no less, which I think is important.
So Alchemy's out there and people are using it, and it's good developer experience and much better than what we have in infrastructure as code elsewhere. But then let's move on to the effect part where I started interacting with you around the ideas of doing some of the stuff with effects, and we called it infrastructure as effects, which
I think you coined that term. That's a good term. I'm taking that, man. that's a good one. I like it. IAE. It's so good.
Yeah.
Yeah.
Yeah. So you with Alchemy and Effect, so there's the core Alchemy module, but then there's the Alchemy, like a more effect-oriented module or something like that. How's that work?
Yeah, good question. Right now, the focus is our proof of concept of that. Like, does it work? I'm taking some lessons of things that went wrong in the core of Alchemy.
Like is this different a total, like rewrite of Alchemy, really like centric to effects, or
it is right now. So it's very focused on AWS. And it is a total rewrite at the moment. I do think there's a story to integrate. Like I don't want to. We're not going to throw it all away. I also need to test this concept. Like effect is also, a subset of the JavaScript community, right? So there's certain risks that come with that. But right now, it's a total rewrite of what if I reimagined infrastructure as a code again from the perspective of effects. Like drop all the async stuff and just go straight for pure effect. That's sort of what that is. And we'll be able to build integrations and share code, but right now it's not that important to share code because I'm focusing on AWS. Primarily because this flagship feature of inferred IAM policies is much more relevant to AWS than Cloudflare. Yeah. So that's why that is that way. Yep. But go ahead.
Let me ask, okay, I know you've only been exposed to this for a relatively short time, but it seems like you picked stuff up pretty fast. And I ask this question a lot because I'm trying to figure out how to explain it to people. How would you describe effect and effects, not effect the library, but the concept of what is an effect and what is an effect system?
Oh man, I'll first off, I'd like to say I just figure things out. I definitely don't read the books, so I hope I don't give a terrible definition.
There's plenty of them out there, so you're not going to hurt anything.
And as some background, we wrote our book Effect-Oriented Programming and shipped it last fall, and it was based on Scala because that's what our other co-author Bill and I knew best, and we used the Zio effect system. Mm-hmm. But we're working on a TypeScript effect version of the book. And one of the things that we're wrestling with is how do we explain what effects are and why they're helpful? And so that's where we ask everyone, like how would you explain this? And hopefully that will help us get to a good opener chapter.
Yeah, well, it's maybe one way of explaining is it brings all of the actual side effects of your program into the type system. That's the most important thing that I notice about effects, right? So like when you write a program, there's always this side channel of like what's actually happening, right? What's actually being affected in the world by your program. And as a developer, you're keeping that in your head intuitively, but it's not there in the program. The program doesn't actually know that, but effect moves that into the static type system. So that, and you could talk about errors, but I feel like that general concept of like moving all the things your program does are known by the compiler. I don't know if that's a good definition, but it's definitely
it's a good piece,
tickles.
I think.
Yeah.
And then for you there with the Alchemy effect, there's probably some benefits around the like graph piece of that, like the ability to like establish a graph of dependencies and
I would say that it's like, so it's another thing. Yeah. It's like I like Michael Arnaldi, I think said this, like representing your whole program as data structures, right? So each effect is just a data structure. It carries logic, like context, dependencies. It returns some value and it has some error, right? So
it seems like that fits well with
infrastructure,
right?
It's declarative, right? Like that's like it's purely declarative. Like here is a computation. here you go. I've given it, like, in my hand is a computation. Here you go. No, it's not a running computation. I haven't given, it's not doing anything right now. It's just a little packet with a computation. And you can go do what you want with that. You can move it over here. You can run it again. Like, so it's like we got to pass around a computation in a purely declarative way. And yeah, what is a cloud application at the end of the day? It's a computation that runs in some context, which is an infrastructure context. It has some flow and it returns some value or some error, right? So it represents, to me, the most exciting part is the context followed by the error modeling. Type-safe errors, so important, especially for AI. But context is the unblocker. Like, I'm running in AWS with these dependencies. Beautiful. That's what we needed. Yeah.
And then you, in the world of IAC, then you can look at that in your IAC tool and be like, oh, we can create the right IAM rules. And then do you go as far as actually being able to infer, like, okay, I need this effect takes an S3 client or whatever as a dependency. Mm-hmm. That must mean that I'm going to need to create a bucket, or is there still kind of some manual, thing you have to put in there to be like, here's the bucket I want you to create, or how does that work?
Yeah, so you declare a class. Maybe I should share my screen. Maybe you want to try sharing the screen here? Would that help? Yeah. Or, yeah. We can try it. If it doesn't work,
For those just listening, we'll try to explain what's happening, but we now have the ability to share screens, and this will be on YouTube, so people can watch.
Oh, yeah, it needs to be much bigger.
Yeah, I'll zoom in 1 second. You tell me when it's enough. How about? I'll get rid of that.
And if you get rid of the sidebar, yeah, make it a little bigger, please.
A little bigger.
Yeah.
All right. Is that okay?
Yep, I think that looks good.
Okay, so
some effect code. We see some things that well, I guess tags, but those aren't the effect tags. These are different tags.
Yeah, so these tags, so you define you say I have a resource, right? So my application has a Lambda function, right? And it's got a name. So you can define this, and now you can refer to this anywhere that you want to, for example, call this function, or refer to
a Lambda function, you mean AWS Lambda?
Yep. So these model the resources specifically. So there is an idea we could get to, which would be, cloud agnostic modeling. I'm less bullish on that because you actually want the uniqueness of the cloud rather than a general cloud. But we could do an effect platform, cloud platform. There's definitely an idea there that could be pursued. But yeah, so then you define your business logic. So I like to think of a cloud application has what? It has resource declaration. So these are the resources that are part of my application. Then there's business logic independent, or business logic defined in context of those resources. So you can see an example here is I'm calling q.send, right? So I have another resource called messages, which is an SQS queue. It's a FIFO queue, so you specify what type, and you also can specify the schema of the data that's inside that queue, right? And then I can just call q.send. And you'll notice that there's a beautiful symmetry between that and the IAM policy. Right? So q.send is effectively SQS:send policy. That's what you need, send a message. So I infer that at the type level. We know of this. You can see that in the types, in the context, we depend on q.send message for that specific queue, the messages queue. So we bring that requirement of a policy to the context, and then later on you explicitly provide it. Right. So you can see here when I actually make the Lambda function. So that's the infrastructure. So there's business logic, the runtime handler. This is actually what's going to be bundled and put in Lambda. And then there's the infrastructure. This is the thing that will run to deploy it, create it, update it, delete it, whatever. Right. So these are your pieces that you have in a cloud application. And you still explicitly provide it because I like the opt-in nature. So you can see that if I uncomment this q.send, I get an error here, and it says the policy of send message is not assignable to policy of never. So basically, this function here has no policy requirements, and you gave it one. So that's an error, So I can just remove that and it goes away.
Yeah.
If I add it back, it comes. If I say I need another policy, I get an error because I've oversubscribed, right? So it's saying policy of send and invoke is not assignable to only policy of send. So it's invariant over its policy statements. So it's inferred at the type level, but you still explicitly have to provide that runtime value. And I like that because it keeps the developer conscious of what they're doing and what they're authorizing in their application. Does that answer your question?
Yeah, I think this is amazing. The fact that you can use the layers for not just like the layers that an application needs, but the layers that are needed from the infrastructure as well. And, and then get all the nice type safety around that.
It's almost like this. I sometimes joke and call it the Holy Trinity. I don't really know why I call it that, but it's a cloud application is like this triangulated thing, right? There's this symmetry between the infrastructure and the runtime. They are not independent. They run next to each other and they mirror each other. So you can sort of see that there's a runtime layer. Those are your clients. So at runtime, you need the clients. At infrastructure, you need the policies. And then there's the business logic. So business logic, infrastructure, and clients all come together to form the cloud application. They're all separate, but defined in relation to each other. So that's what you can sort of see modeled here. And this can be
I really like this approach, but I could see some people being concerned about weaving together infrastructure definition with application definition. But for me, I'm always like, why did we separate out those two things in the first place?
Yeah, well, at the end of the day, it becomes an optimization problem, right? So infrastructure code has a legacy of being very heavy. With Alchemy, it's lighter, but it's still heavy, right? You've got bundling logic, so maybe you've got ES build in there. That's not very portable. Maybe it can't run in a Cloudflare worker, right? Maybe it can't run in a Lambda function. So there's portability and heaviness. But you're right, they are the same thing. You can't actually separate them. Us as developers, we're just sort of connecting them in our heads, and we spend all this time like, oh shit, I forgot the policy, and you find this all out because they are linked. But to your point, I've shown them in the same file here just to demonstrate their symmetry. You don't have to do it this way. Like I can imagine. Let me bring back my sidebar. Like I have here's the index, right? So this is actually where we bring it together. There'd be nothing stopping you do this, right? Bring all the infrastructure into one place, and then leave this as just purely business logic, right? So this API value here is just a business logic. It doesn't have any of the actual runtime layers. So I can execute this in my unit tests. This is the perfect thing to grab onto for unit tests. But the exported handler, this has the client, right? See, I'm saying get the client from the environment. So that is perfect for bundling. That becomes the bundling piece. So you can still separate them if you want to keep infrastructure separate, but just remember that they are defined in relation to each other. There's no actual disconnection.
Yep. I think that makes sense. Is like at some point the two need to come together, and when and how you do that, traditionally has been a source of a lot of pain. It's like, this thing worked locally, and I push it and deploy it, and now, I forgot to configure this thing on my infrastructure side, and so it doesn't actually work. And I'm sure you see so many headlines that identify like outages and from whoever on the internet, and it's always like, there was an infrastructure deployment that was broken, and it's like, why are these things so decoupled that we can't actually know when there's going to be a problem before we actually go to deploy it?
Exactly, because if you think about what is the developer having to do, every cloud developer is effectively a compiler for their program. They look at their runtime code and they build a mental model of like the resources it needs. And then they go and manually write those, and there's no one telling them they're wrong. The only thing that tells them they made a mistake was deploying to AWS. That's the only thing they could possibly know that something's wrong. But if you connect all those things statically, like I've shown here, the compiler can tell you that instantly.
I guess that's a good metaphor for it, is that We essentially do dynamic binding to our infrastructure today is the predominant way that we handle that. And what
Yeah.
you're saying is we can actually get to a static binding between our application code and our infrastructure in a way that allows us to verify before we deploy that
Hmm.
the right things are going to be there because it's statically verified.
It always
That's right.
seems like it comes down to this problem of, oh, we'll solve this little problem deploying an application, and we can hold that in our head. And then things start scaling up, and we're still trying to hold that stuff. It's almost like assembly language programming. It's like, oh yeah, we
Hmm.
can do this. And then eventually you need a compiler,
Hmm.
and the tooling is what we need to be able to continue to um, increase scale on these
Hmm.
kinds of projects.
Yeah, and people are that idea of, look, this is a compiler problem has been around for a while. Like, for example, there was a programming language called Winglang that attempted it. Right, it looks very similar to TypeScript, but they had a concept called pre-flight and in-flight, and that was a model of this: in-flight is code that runs in the Lambda function. Pre-flight is code that runs in the infrastructure time. Very similar to like a Scala macro or a C preprocessor, or what's the other one? Scala has similar things like the implicits, right? Very similar to Scala implicits, but every time you do that, you run up against the wall of most people don't want a new language. We have an amazing language. At least I'm obsessed with TypeScript. I used to be obsessed with Scala. Scala 2, I never didn't stick around long enough for 3. How can we do this in the language in a principled way? And the last missing piece, for me at least, was effect. Was how do I capture dependencies between runtime code and infrastructure statically?
Yeah.
And that is what an effect enables. And not to mention all the amazing benefits that effect has elsewise, right? Like, I can't wait to build stream processors and SQS queue handlers with like amazing declarative retries and type checking of all the errors. Like, oh my God, there's so many
And
other benefits.
configuration. I think you're going
Yeah.
to be able to get to the place where configuration, when you want to like, okay, this thing calls this thing, but I've got to have like the ARN or
Yeah.
the domain name, the URL to this thing.
Yeah.
Like that is a source of a lot of production issues today, and essentially you could statically then even wire configuration across these different services as well.
Well, that's like, I didn't really point that out, but that was already in that example.
Oh,
So like, you
nice.
you saw at the end when I basically created the Lambda function infrastructure, I added in, that wasn't just the policy. It's calling it policy might be the wrong word. It's actually a binding. So that includes permissions and environment variables,
Nice.
two things
Yeah,
together.
that's awesome.
So that queue, that if I call queue.send, it knows how to look that up in the environment by its ID, which is the benefit of the tag. Like, I used to really not like tags, and then I figured out, oh, it's just it literally is a tag. It's a reference, right? So I have a queue. It has a logical name. If I need to look it up in infrastructure or runtime, I have this stable reference for it. So
Tag is
that's
just like
already
a
in there.
handle. It's like a handle that you can
Handle.
pass
Yep,
around and
that's
use
right.
to connect from one thing to another.
But without bringing baggage. That's the other thing. So it's a handle. Like, so if I was to give you a resource instead of a handle, you're bringing all the create, update, delete logic that you don't need in your runtime. You just need to know its name. So what tags are good for is that decoupling. It's like a reference, and then there's a mapping between it and some other value where you need in some other context. That decoupling is the closure serialization problem that we were trying to figure out before. We don't need to do that. We can just decouple with sound, principled engineering practices and conventions. Yeah.
Nice. This is awesome.
Yeah. Okay. So I've struggled with tags also because I've tried to drill in and see how they implemented them,
Mm-hmm.
and it seems like it's a solution to the structural typing problem. So you need to have an actual name,
The nominal
solid
type name.
identifier for a thing rather than just, oh yeah, it's the same shape, so it's good enough. Is that your perspective, or do you see it in another way?
I I think it is that it's basically the tag is the nominal type, I guess you could say, right? So yes, we have structure. We emulate nominal typing with discriminator fields on a structural type, right? So it does model nominal types because you want to basically say it's a unique thing, and then that handle maps onto something else. So I would agree that the tag is the nominal part of the type.
Okay. That's the conclusion, but I just thought maybe you had some other insights that. Maybe
Well, the reason why they export the class, like I start to do this a lot too, is you also want to prioritize user provided names in your. So the string is not enough because you end up with this insane structural type and nothing makes sense anymore. When you extend the class, so it's called a mix-in, you create the class programmatically. Now, that's why you saw lambda.invoke function, and it's the name of the class the user provided. They know what this means in their head. So that's another benefit of, that's why it's not just const. The reason it's class is to give friendly names, or at least that's what I like about it. Yeah.
Nice. This is, I think a glimpse of the future. And I think what you mentioned with like Wing and some others is there's been some attempts, but for me, what makes this totally viable is the fact that it's built on TypeScript. Like you didn't have to go invent a whole new programming language to get there. And then it's built on effects, which are able to model the dependencies, model the not just the inner application dependencies, but the dependencies to the infrastructure as well. And then being able to create all the like plumbing that's in the middle of those things, whether it's configuration or IAM policies, or I'm sure you'll get to VPCs if you haven't already. And so all those pieces that need to come together. But one of the things that I wonder about is there's a lot of different ways, like on AWS, that you can run your stuff. And how explicit should we be in our IAC or in Alchemy Effect about the actual runtime that this thing runs on? Like where should that go? So as an example, like with a Lambda, you could specify like memory, how much memory the Lambda is going to get, or what instance type it runs on, or some of those more operational pieces. And where should that kind of information live?
Yeah, just off the top of my head, I would say things that are invariant, for example, whether a queue is FIFO or not, should go on the tag. So anything that's invariant goes, like, think of the tag as the most static part of the application. And I'm sorry, I don't know why I can't kill my Discord. I keep giving that notification. Apologize for that. Static, unchanging things go on the tag. Changing things defer all the way to the actual part where you make the infrastructure, lambda.make, for example. Yeah. So even with, I didn't show you the queue consumer, right? So a queue can be consumed from a Lambda function, but it could also be done on an EC2 instance, right? That is even deferred till later. You define your business logic independent of whether it's a Lambda function or whatever. And then right at the last moment, you decide, I need a Lambda with this timeout, with this memory, or I want it on an EC2 and this VPC with this instance type and this many parallel or something like that. So I would say changing things at the end, unchanging things at the beginning. Yeah.
And then your deployment procedure in this case is just to do like Alchemy deploy or something, and then your Lambdas all get created, your VPCs, your IAM roles, like all that stuff just magically gets, because it needs to be in a graph. There's the dependency graph of that, but then it just Alchemy deploy or whatever is just going to magically do all that for me.
So I'm building the primitives in code as just functions that create effects, right? So there's a function called plan, and plan takes an array of those infrastructure pieces that lambda.make, q.whatever. So you pass those into the plan. That creates an effect that will create the plan. You could then imagine providing a layer which is like approval, auditing. You could swap out different sort of policy checks for permissions there. And then there's another one called apply. So an apply takes a plan and then gives you an effect that provides all the infrastructure, and that has all the types, so the function URL and all that. So it infers all the types. And then finally, if you call effect.run promise on that, it will actually do the work of deploying it. And you can do that manually in code. I'm a big believer in library primitives first, CLI second. But I could also imagine skipping those things and deferring, letting the CLI put in the plan and
But you're just running a TypeScript program, right?
That's right.
That's the way that you would apply the infrastructure change. Is it's going to all be in an effect, but then you effect run promise and you run that TypeScript program, and boom, your infrastructure
gives you the data,
be provisioned, including your Lambda functions and everything that's needed.
And I really one thing I think is really, or at least something I really hammer on, is I've always hated CDK and Pulumi because they never let me get access to the data. Like it has a function URL. I've got to go through some abstraction, like outputs and exports, just to log the URL. Where effect.runPromise just finally materializes that lazy, pure data structure, which is your infrastructure. It materializes it, just gives it to you. You can log it out normally. I think that is a important property to keep. And something that I really pushed on early with Alchemy, even though I did it with async functions, was it's an async function because I want you to have the data. I don't want you to have some lazy representation of the data that you don't know what to do with. You can't await. No, I'm going to give you the data. The only problem with that was we lost planning. And when you lose planning, I think you lose enterprise. I think you lose, a really valuable portion of ISC, which is being able to review and audit the changes. So with Effect, I think we get the best of everything. We get the laziness. We also can get the data, and we get primitives that are in pure TypeScript that don't bring any baggage along with them. So
nice. And then on the CI/CD side, the story is the same. I don't have to have like something weird or different to support CI/CD. I just take that TypeScript program and I run it in my CI/CD, and boom, I've got my deployment of infrastructure and all of infrastructure, the application and the provision, the infrastructure that needs to be provisioned.
I think there's a big story developing here that I'm very excited about, which I call version controlled infrastructure. So the closest thing to this was Unison language, which is compiles a program to content. Every function is content addressable. So you can imagine it as like this. You can always look at any version.
Maybe a couple of years ago now to talk about Unison, but love Unison. Like they're, I think directionally they're headed in the same direction of what you're trying to achieve, just very different ways to get there.
Yeah, the hard part is getting the primitives right. Version control data is a hard thing, right? But if you're using Neon and PlanetScale, they now have primitives called branch, right? So if we start building some of those things into AWS, if they start providing branching, one thing that we already do in Cloudflare is like every branch gets its own copy of the infrastructure. Just like Netlify 10 years ago came out with preview URLs for your website. See it before you approve it, right? It's like, wow, this is so great. I want that for infrastructure and data. Let's just go all the way. And I should always be able to go back and look at the state of the data and the application as of that deployment. So I think that's
related to a commit ID. So that was one of the things that Heroku was I think novel at that time was you should never deploy anything that isn't associated with a commit, because you want to know exactly what the state of your source code was in correlated to the thing in production. And
that's right.
Yeah, it just drives me crazy when people upload zip files to Lambda.
There's a lot of funky things that go on. Yeah, but you can imagine take the plan and the statically defined policies and integrate that with a commit and just provide version controlled changelog of all your infrastructure. And if it doesn't build, then it's invalid infrastructure. There's a very cool story developing here.
Absolutely. Oh, super exciting. What else? You've gone through a lot.
Here's a side question. So you're doing this on your own?
I have a small team actually that I've put together. I just closed a small fundraising round of $1 million. So I'll probably announce that soon. It's
That's good.
Well, I look around and I see AI apps raising like 40 million to, I don't know, do some, I feel, but hey, I'm very grateful. It's great. It allows me to focus on this problem for a few more years. And I think, as we develop this out in a few months, this will be working. And I think we'll have people playing with it.
Version will be working.
Yeah, I hope so. I'm very interested to see what people think about the Effect thing. At one side, I'm nervous. On the other side, I'm like, this is what was required to do this. Like, this idea of infrastructure from code has been around a while, and it's kind of always failed. And I think the big reason is people are like, I don't want to change everything I'm doing just to adapt to your infrastructure, right? Like, there's not a big enough reason to go rework your brain to think in terms of these frameworks. But now Effect has broken that inertia. They had a good enough, compelling reason to rethink how we build stuff. That wasn't just syntactic, right? It's semantic. It's real tangible benefits. So with that, piggybacking, I think infrastructure from code, but I think infrastructure as effect, way better name, infrastructure as effect, can finally happen, right? I think there's a new way of coming.
My concern has been, well, in going from Scala to TypeScript is, and as I have dug into TypeScript, is that I feel like, yes, there's a vast number of JavaScript and not as many TypeScript programmers, but still a vast number. And yet, it's almost like the early days of C++ when people are programming in C instead of C++, which is, that was the attraction, how you could get people in. And yet, when you start digging into the more sophisticated or odd features of TypeScript,
Mm-hmm.
I feel like most people don't have, this tiny fraction of people really understand the depths of TypeScript.
Yeah.
So my concern is that Effect uses these things. It seems like it uses the whole language on all the little bits and pieces.
Yeah.
And I'm just wondering how many people are going to be able to truly grok that.
Yeah. Well, I agree. It takes a top tier TypeScript developer to build Effect.
Yes.
But if you look back at the thing, for example, the class, like this little thing of a mixin class that they're using, that's a subtle little detail to cater to non-TypeScript developers, because it reduces this big complex type to a name, and people know type names. So I think there's an art here, and I think Effect is doing well, and will continue to do better. And it's something I'm focusing on a lot is, yes, use the language to solve these problems, but you provide a nice experience to the user. They get to float on top, and just they replace await with yield star, and the rest just flows, right? Or at least I hope that is what we get to. So I agree, but I also would say, not that AI is going to take over or anything like that, but for AI programming, Effect has real benefits, right? Declarative errors, static errors, and declarative retries. So easy for AI to generate. How many times has AI generated a retry back off for me? And this is gnarly, right? So there's also an argument to be said of more AI generation helping with using these tools. But yeah,
Well,
I think they're going
to. One thing we haven't seen on that yet, but will, is when we have MCP servers. And I know there's now the MCP server for Effect, which I've tried, and it's pretty helpful. But I think it can even go a layer further, where it would have knowledge of the layers of the error types, of all this kind of stuff, and even hooks into the compiler that would allow the AI to actually have much better knowledge of the types and the structures and everything that's being written, and be able to provide even better code assistance than what it does today.
Well, and I also think as we get to the point where we can develop custom LLMs that are small and focused and can run locally, they'll be able to be much more helpful in explaining some of these, generating the things, but then also explaining what's going on, so that people can understand it that way. That's
so on the MCP server side, Scala has actually been one of the places that's been pushing this like deep integration between the Scala MCP server and the compiler, and so that then the MCP server can essentially be like hooked into phases of the compiler, which then can allow the AI that's using that MCP server to get better error message or better error messages earlier, like
Yeah.
ASTs. Like, why not give the AI the like AST of
Yeah.
something? So yeah, I think there's a lot of innovation that'll happen that Effect and TypeScript have a lot of opportunity around.
I think even TypeScript announced that part of their move to Go was so that they could do more static analysis for AI. That was in one of their blogs, and I think one thing we'll see as well, or we're already starting to see, is building linters for AI. Right. So with TypeScript moving to Go, there's already an ESLint port in Go. And the reason why that's important is because you can use the type system for your linters, not just syntactic linting, it's type system linting. And you also have the Effect language service plugin, which does work to clean up some of the error reporting to make that a little bit more digestible for people. So you'll just see, I think, AI, I view it, it's like a train. It needs to be put on a rail, and those rails are the type system and linters, right? And that information that keeps it on a rail, and it also can provide information to help debug. So that can help answer the, how do people who are less experienced work with the tools? But I still also think designing the TypeScript framework developer must keep this in mind and make sure that all their errors and all their types actually export in clean ways, not here's a crazy 45 different definitions of the structural type, right? Most people just glaze over that. So and you'll notice like my policy error messages, for example, almost look exactly what CloudFormation would tell you. Lambda dot invoke function of this is not assigned. That's pretty normal. That doesn't look too crazy.
And
or at least to me.
you can get those at essentially compile time instead of waiting a few hours to get your
cursor can see it now. I don't have to build an MCP. Cursor can see it already.
And presumably we'll be able to move from not assignable to something more meaningful.
Right. Yeah. Hey, you forgot this policy. You're missing this policy,
that
right?
Would be much, because not assignable to, I'm going to have to go through. Oh, what is it? Oh,
how do I fix this?
Yeah. I don't know actually what the problem is.
Yeah, I think Effect also offered something like that. They're doing something for the errors already. They're cleaning up the error messages. And Michael and Ali said something like, "Oh, we could maybe do something for the policies as well." So I don't know what that looks like, but I can imagine grab those types, reframe it into you're missing this policy. Did you forget lambda.invoke function?
Because I think Zio does that a lot.
It was Kit that is now at Effect who added a lot of the really nice error messages.
Right. Yeah, because it's like rather than going, I couldn't do this. It's like, here's what's wrong. That's way better. So we'll probably see that. So it's good. We need to interview Kit.
We'll have him. We had him on once, I think.
But
we need to have him on now
that was a while ago, and I want to know his perspective on A, Effect, and B, just TypeScript. And anyway, a bunch of you'll have interesting.
Kit's videos are amazing. I've been following.
So it's like, I've never seen this approach before.
Yeah.
So good. All right, Sam. Well, thank you so much for Alchemy and all you're doing there. I think it's really helping the world move forward into a much better place and hopefully alleviating all of my issues with IAC. So
make the pain stop.
Thanks for having me on, guys.
Just groan and beat his head against things for hours.
Anytime I have to go into IAC land, it's just like going into the pain cave.
Oh yeah,
it hurts. It hurts, and I don't want it to hurt anymore. So, yay, Alchemy in Effect. I think it'll get to a place where it doesn't hurt anymore.
I'll do my best, man. Well, I'll have something for you to try very shortly. I think by the end of the weekend I'll have showing the plan and the nice TUI with like the deployments, and I'll put out a branch and you can start playing with it if you want to. So appreciate it.
Can't wait. All right. Well, thank you.
Thanks, guys. Thanks for having me on. See you guys later.